In this problem, coffee is draining from a conical filter into a cylindrical coffee pot. The filter is 15 centimeters tall and has a diameter of 10 centimeters. The level of coffee in the filter is decreasing at a rate of 4/3 centimeters per second. Part A asks, at what rate is the volume in the coffee filter changing? So first off, if there's not a picture provided, draw it. It will help every time. So with this, we're looking for volume. And for a cone, volume is 1/3 pi r squared times height. And the problem here is that we have two variables. We have the radius, which is half of 10, so that'll be 5, and the height, which is 15. So we're going to have to find a way to relate one to the other. So set up your proportions. We'll have 15r will be equal to 5h. So we're looking for r. R will be 1/3 h. So we can plug that back into the volume formula. Like that. So we can simplify this down to 1/3 pi times 1/9 h squared times h, which will further simplify to 1/27 pi times h cubed. Now we can take the derivative. So dv dt will equal 1/9 pi h squared dh dt, which will simplify. We can start plugging things in now to get 1/9 pi times 15 squared times 4/3. And we will end up getting dv dt will equal negative, because the level is decreasing, be negative 100/3 times pi centimeters cubed per second. Now on to part B, which says, how fast is the level of coffee in the coffee pot rising if the pot has a radius of 10 centimeters and a height of 25 centimeters? So we set up volume formula, which is just going to be pi r squared times height. And since the radius isn't changing, we can just, like, dRdt will be 0, so we can just plug in the radius. So volume equals pi times 10 squared times h. So volume, we can do and take the derivative, dv dt equals 100 pi dh dt, and we know dv dt, but it's going to be positive this time because it'll be increasing. So it'll be 100/3 pi equals 100 pi dh dt. And now this will simplify down to 1/3 centimeters per second equals dh dt.